look like some irradiated water?
Not really.
It's from the sponsor.
I don't want
Radiant water, drink it!
it.
Drink it! Taste the radiation.
Tastes like poo.
I'm here to teach you about astrophysics.
Astro Boy! Yeah!
No, astrophysics, the science of the stars.
Star Wars!
No, astrophysics. Astrophysics. Get it?
Yes, mister.
That's Professor Mister to you. The sun is constantly fusing hydrogen. It fuses 2 hydrogen nuclei into 1 helium nucleus.
Oh.
Close enough. When this nucleus is created, it is very, very unstable. And it undergoes beta-positive decay. Beta-positive decay.
Ah, Mister, that
That's
hurt.
Professor Mister to you.
Professor, Mister, that hurt.
It undergoes beta-positive decay. It emits a positron, which is a positive electron, a neutrino, and 2.3 times 10 to the negative 13 joules of energy.
That's not very much energy, Mister. Professor, Mister.
It is quite a lot of energy when you take into account that the sun is 92% hydrogen, and it takes up quite a lot of the mass of our solar system. Stop that, it's disgusting.
What happens when the sun runs out of hydrogen and...
It'll explode. Well, not explode, just get bigger and bigger, because it fuses the hydrogen and the helium into bigger elements. It'll get bigger and eventually destroy the Earth.
We're all gonna die.
No, modern estimates suggest that the sun has enough hydrogen to last another 5 billion years or so.
I don't wanna die.
Don't worry, by that time everybody will be dead due to nuclear winter anyway.
But what's nuclear winter?
Well, if everyone fires their nuclear missiles at each other, all the radiation it'll, just forget it.
I'm gonna die.
You're not gonna die. You're Superman. Get a better kid next time. This is the Hertzsprung-Russell diagram. It helps us define stars. On the x-axis, spectral type and temperature are measured. On the y-axis, absolute magnitude and luminosity are measured.
But how do you plot 2 things on the one axis?
Because, Willie, if you plotted absolute magnitude against spectral type, it would come up the same as luminosity against temperature. Any other stupid questions?
No, mister.
Good. This is the main sequence. This is where most of the stars are. These are the supergiants. That is the Latin term for supergiants. These are the red giants, and these are the white dwarfs. When our star was born, it started around here. As it is slowly burned through its hydrogen shells, it ends up here. As it goes through the stages of being a red dwarf, red giant, it'll slowly go around here and end up as a white dwarf. A star 10 times bigger than our own star would start around here, enter the main sequence, slowly burn through its hydrogen shells, becoming a supergiantess, and end as a black hole. A star 1/10 the size of our own would start around here, become a relatively small red giant, and become an absolutely minuscule white dwarf. What you drawing there, Willie?
I'm drawing a picture of me and my house and you, and you're on fire and dying.
Well, our star puts out light that's yellow, meaning it's not very hot.
I hate our star. It's not very good.
Well, what would you want it to do?
Be the bestest star in the whole galaxy.
Well, our star is 1 solar mass, and it's the star that every other star in the universe is measured against for mass.
What's solar mass?
Well, solar mass is the weight of a star due to mass, according to its mass. 1 solar mass equals roughly 2 times 10 to the 30 kilograms. That's pretty darn big.
It's pretty small. 2 times 10 to the power of 30 equals 20. 1. It's not very heavy. I weigh 44. Take away. I'm heavier than the star.
If that's what you want to believe.
Yay!
Eventually, there was enough stars in the universe that they'd all come together, creating galaxies. You know, there's a few types of galaxies. There's spiral galaxies, regular galaxies, and elliptic galaxies.
There are there's the regular galaxy, and it's a big bulge in the middle with a disc around it of stars. And
Like my dad?
your dad's got a big disc around it with stars.
Yeah, well.
Right, moving on. Spiral galaxy is a galaxy like the regular galaxy with a disc around it, except the disc is broken up into arms, which are not arms as in long strands of stars. And the arms are created by tidal forces, which are caused by nearby galaxies, just like the way the moon causes the water at the beach to move in and out. Spiral galaxies have the big bulge in the middle of both spiral and regular galaxies are most probably supermassive black holes.
Oh, what?
A supermassive black hole. A supermassive black hole.
Alright.
And so, but as the age of the galaxy progresses, the stars move inward, which means the closer stars are to the centre of the galaxy, the older they are.
Can they pull each other into each other?
Yes, they can. That would cause an elliptical galaxy or a regular galaxy. So if the masses of the two galaxies that collide into each other are similar, it will cause an elliptical galaxy, which is much like a big centre in the middle with stars straight outwards. But irregular galaxies have no big centre, they just have a random array of stars.
Thanks for teaching me that physics.
God, kids, I hope that this can just... Next time, get a proper kid, alright?